In this video, we are going to learn about acid-base titrations and how to calculate an unknown concentration for either an acid or base given the balanced equation. You can react an acid and alkali together in a controlled way by either adding the acid or the alkali to its opposite using a burette until neutralization is achieved. This is a process called titration. Once an indicator has changed colour at a specific volume of either acid or alkali, you have met the endpoint and the titration is complete. Let's consider this example of neutralization. Given the equation, you pipette 25 cubic centimetres of a sodium hydroxide solution into a conical flask and titrate it with a standard solution of 0.1 molar hydrochloric acid. Using a suitable indicator, you find that 25 cubic centimetres of the acid was required to neutralise the alkali, as found by the titration. This is the endpoint for the titration. You can now calculate the concentration of the sodium hydroxide in moles per decimetre cubed. Using the information, what do you know? Pause the video, write down the reactants in a table like this, and continue when you're ready. Record all the information you know about the acid and the alkali in the table. Your completed table should look like this. You know the concentration and the volume of the acid used to neutralise the sodium hydroxide. This is 0.1 molar hydrochloric acid and 0.025 decimetre cubed. The next step is to use the formula triangle to calculate the number of moles. Add this as a row to your table. Use the formula triangle and calculate the number of moles. Pause the video and continue when ready. The concentration is found by dividing the number of moles by the volume in decimetre cubed. Your table should now look like this. If you look at the ratio of moles of reactant in the equation, they are the same. So the number of moles of sodium hydroxide is also 0.025 moles. Again, using the formula triangle, you can now find the concentration of sodium hydroxide marked with a question mark. Try it now. Pause the video and continue when ready. The correct way to do this is to divide the number of moles by the volume in decimetre cubed. This means the unknown concentration of sodium hydroxide is also 0.1 moles per decimetre cubed. Did you get it right? Here's a challenge. 10 cubic centimetres of a sulfuric acid solution was titrated with 0.05 molar potassium hydroxide. If the acid required 20 cubic centimetres of potassium hydroxide for neutralisation, what was the concentration of the acid? Follow the steps as before for this calculation. The blank table is displayed, the formula triangle is displayed, and so is the equation. Pause the video and continue when completed. Your completed table should look like this. The correct answer is that the concentration of the acid is 0.02 moles per decimetre cubed. Note there are half the number of moles of acid because the ratio in the equation is 2 to 1, where there are 2 moles of potassium hydroxide and 1 mole of sulfuric acid. Did you get it right? In summary, the steps are 1. Have a balanced chemical equation for the neutralisation. 2. Set up the table as shown. 3. Use the question and write down all you know about the acid and alkali, marking a question mark in the cell to remind yourself what you are calculating. 4. Use the concentration formula to find the number of moles from a known volume and concentration. 5. Use the mole ratio to determine the number of moles of the other reagent. And 6. Calculate the concentration using the concentration formula triangle.